Hello as well. We are coming back to this kind of a video that you have to do with vectors, and they give us two magnitudes and they want us to do a reference angle and actually give an angle to, and give it the coordinates of like what we want to do for the vectors. And number A, which the x is according to what I have from the question is cx equals 3 feet and cv is 6 feet. I'm going to just use feet because they don't ask us to have this in inches, but they might have you ask that. If you have you like to get inches, I don't know, whatever coordinates they want from you, you just have to convert to that. Now remember, if they have feet square, just multiply these two to get a feet square, or do whatever to get a feet square. I mean, maybe give it a square, the factor to get a feet square, but we don't need this for now, so this is kind of a tangent line, which I'm not going to talk about that. But we have 3 feet and 6 feet as the coordinates for what we need. So cx is going to be 3 feet, and I have my reference hats. X hat is going towards the right. That's what the question wants us to do for x hat, and the y hat is pointing up, as the question wants us to do that as well. So we have cx, which is 3 feet. So if that is positive, then it's going to the same direction as our x hat. So you're going to have cx, that's kind of 3 feet, so you're going to have that towards the right. Now, I don't want to do 90 because my professor doesn't want to, and I don't feel right. I think 90 and 180, it makes it like more simple to get these angles. So for me to be challenged, I have to do it like somewhat that I at least get an angle that challenge me to draw the vector correctly. So I can have CV, which is 6 feet, towards the up right. So I know it's positive because it's positive, I have to do it up. And I go for 6 feet, which that creates an angle of 20 degrees between them. That's what I call. That's what I see from the picture. I don't want to trick myself, but there are professors that I had a geometry teacher who told me you don't have to trust, you can't trust the drawing, you have to like do that accurate or stuff like that. But my professor doesn't need to, and I don't want to also ask trick questions. So that's 20 degrees. For B, we have dx of negative 5 feet, which if it's negative, then it has to go towards the left, because if positive x hat goes towards the right, the negative has to go the opposite direction, which we do. Now I have done this a little weirdly because that one goes a little towards the bottom. Well, so you have our dx, which is a 50 degrees angle between them because dy is 15 feet, and I draw that does look like 3 times bigger than this one. And over here I actually draw the cy, so it's like twice as long because there's 2 relation here, and then there's 3 relations as well here. And that's what we get for trying to do these vectors with hand. Hopefully you guys understand. And oh, okay, I forgot something to mention right now. We also have a z-hat, which is coming outside, which I don't have the z-hat for any of this. So if I don't have a z-hat, then that means I'm not going to even use it. So z-hat equals to 0, so that's the z-hat that we have. We don't have a z-hat to work with. So also have a c-hat, which is, they're going to ask you much more in physics, but z-hat's also a component that we need to get from it. Okay, that's pretty much it about these vectors and drawing them on. So hopefully you guys understand vectors. If you have any questions, let me know, and I see you guys in the next videos.